I like to talk about cognitive bias and testing for that in AI systems. So what can go wrong? Well, there's a lot of things that go wrong, and we'll talk about how we test AI systems, the origin of bias, identifying bias. Basically, it all comes down to learning. So I do want to start just a little bit about testing AI systems. It's different than anything you've ever done. You know, how do we test? We look at expected results versus actual results. Well, when we're testing for bias, the actual results are just not that clear-cut. So what do? How do we test it? Well, we have to teach. The AI has to learn. And it has to learn in the same way we learn. And then we have to test, so we have to train it. And then we have to test that it has, in fact, learned correctly. Easier said than done. How does it learn? It learns from data. So, an example in learning. I had a friend. She brought her little boy, who was about 3. He had a dog. He saw my cat. Puppy! Well, why wouldn't he say puppy? A puppy has 4 legs, a head, 2 eyes, a tail, 2 ears. What's the kitty have? Same thing, right? So the thing was, he had not been exposed to cat as training data. Now, when you're assessing the training, you have to look at the bug versus bias. We all know what a bug is. Bug is a discrepancy between actual and expected, right? A bias is different. A bias is systemic. It's an inflection of decisions that produces results that aren't consistent with reality. Doesn't that make you scream as a tester? How do we fix that? Well, it's not easy. So let's look a little bit at the origins of bias. Well, as I just said, a bias is something that is not, it's something that we hold true, but it is not necessarily true. So we could easily, what can go wrong? We could have a real mess on our hands if the AI is producing results that aren't true. So what's it come down to? What's the origin? Anybody? What's the origin of bias in AI? You got it. Data. But it's a little bit more than that. It's a little bit more. Data is what we're giving the system to work with, but what else is it? Look at the person next to you. It's every one of us. We are human. We all have biases. So now the problem gets even more tricky because we have to deal with our own biases as we train the data. So I kind of liken training AI systems to teaching a bird to talk. Well, my sister and I had a bird when we were kids, and we were always trying to teach it to talk, except my mother had to be the one to clean the cage, and she would be cleaning. Oh, what a dirty bird! She didn't like the bird, but that's another story. So what happened? Dirty bird, dirty bird. The bird called himself dirty. So what's happening? It learned something that we didn't want it to learn. So that's the next problem with bias in AI. So now what do? We have to identify it. Well, we start with, can software be biased? I would say so. I mean, it's not clear-cut always because domains can be ambiguous. There's no single right answer, and that uncertainty is what we have to get used to. We don't know quite why it's responding as it does because we can't read the code. Now, we don't know why it's going to respond the way it does, but the one thing we do know is that we as humans have chosen the data. We look carefully at the data, we set criteria, and we run loads and loads of tests, but we still compare the results, and we know what we input, but we can't always tell how it's going to come out of the algorithm, so it's complicated. We can adjust parameters, and still we may not know. So what do we do? Well, we got to look at some examples of the bias data. Remember, does anybody know of the Amazon example? So Amazon built a bot to crawl through resumes. And what might you use for training data for an AI system for finding resumes for a particular role? What might you want to use? How about successful candidates? Because you want your candidates to be successful? Well, that's what they used. And what the AI came up with, a whole bunch of resumes that were only men. Well, that's not exactly what it was looking for. And it had learned that the candidates for IT roles should be male, which we know is not true. And they couldn't even fix it. So there again, it's the bird. It learned something that we don't want to learn. AI learns from data. If you remember anything from this presentation, please remember that AI learns from data. So let's look at a little how that happens. So we'll look at some of the biases you might encounter. Well, there's a data selection bias. You may not select enough data. You may not select enough data from different domains. The data may train the algorithms. It could overrepresent certain populations. Then there's the interaction bias. Even your interaction, just you and me, our biases can come out in the way we interact, the way we assess the data. And then there's the latent bias. And this is when the algorithm incorrectly correlates data with different ideas and demographics. So in the data selection, what happens? We may choose data that doesn't represent enough sections of the domain, enough conditions. I mean, even something like a weather app can come out biased because maybe you trained it with all summer data. Maybe you trained it with data in the US versus with data in Hungary. And that way we're over-resenting a population. Or the domain changes. That's the other issue we have to consider here. The latency bias, this is concepts that become incorrectly correlated, and that was what happened with Amazon. So, and in the interaction bias, we may focus on keywords that are applied incorrectly. In this example, we had Microsoft Tay. If you remember Microsoft Tay, it was a bot that crawled through Twitter and it learned to talk. It picked up all inappropriate language. They had to shut it down. So, does bias matter? Well, I mean, it's in every possible domain at this point. I mean, it's in anything safety critical to recommendation engines. It will give us the wrong answer sometimes. There can be discrimination. There can be suboptimal results. None of that we want. And software can be biased even without AI. There was a doctor who couldn't get into her locker at the gym because the developer associated doctor with males. So if all software has biases, well, yeah, it's written by people. It's trained by people. People make the decisions. So bias is inevitable, basically. So now we have to be able to test it. Our data, it's difficult. It's difficult. We're selecting all different data, but we still may not get it right. We have to really watch the subjective and contextualness of our data. Recommendation engines. Well, here's another story for you. I bought a pair of Ghost running shoes for a friend of mine. And then Amazon asked me if I'd like a hood, a dark hood, a ultraviolet flashlight. Thought I was going ghost hunting. Well, was that a big deal? Not really. I mean, they lost a sale. If they'd offered me a singlet, maybe I would have purchased that as well. But it's not a safety critical issue. So now let's get into the testing. Well, the challenge is validating the requirements. The thing is, our requirements can be changing. How do we determine what the inputs and outputs are? What does it mean to be correct? We have to be able to live with that uncertainty that our answers may not be exact. They're just going to be good enough, you know? And we want to make our criteria as objective as possible, but we have to test with lots and lots and lots and lots and lots of data. Edge cases, edge cases, edge cases in our data. You know, you think a user wouldn't do it, think again. I mean, you have to, and you still can't count on the results being accurate, but you've got to understand the architecture and understand how the network, the algorithms are being assessed. And then what you're communicating to your stakeholders is your level of confidence in the training of and that's a biggie. You know, you say, I have 100 test cases and 50% of them, 90% of them passed. But it's the level of confidence. Has this AI learned appropriately and without bias? So how do we plan our testing approach? Got to think outside the box. We have to know intimately what our users would do, and then some. We have to carefully assess our training data. And if something doesn't look right, don't be afraid to start all over again with new training data. It may happen. You may have to. We want to write test cases that exploit those edge cases. And we have to run as many tests as it's going to take. So when you're estimating your test, way bigger estimate than when you typically plan a test. And you need a more holistic approach to bugs. We got to go back to bug versus bias here. So we want to map our hypotheses to the requirements. We need to establish the test scenarios as we would usually do, but we have to add means and the standard deviations to come up with that, is it good enough? And test using training data, because there's where you're getting your expected result, but you got to make sure that expected result is expected. And then you measure your results in terms of how confident you feel. So when you compare your data, you got to look at it. Is there a consistent match? Consistency is really important. Because it can be consistently right, but it can be consistently wrong. And you want to understand, you got to take more of a holistic approach. Does it meet the goals that were established at the beginning of the project? So you want to take, and when you take that higher level approach, you can go back to your training data and say, yeah or no, don't get buried in the weeds, And that, looking at the higher level will help you not do that. Now, when it comes to your bug review, well, if it's a bug, you got to consider it's a bug or a bias. A bug, something clearly doesn't meet requirements. If it's unrelated to the AI, you treat it as a bug. If AI is involved, then you have to determine what does it mean to be inaccurate? And there could be, it's usually going to be something that you see systemically. Most importantly, test with real data, real life data. If at all possible, you can do a canary release with certain users. And if you can, put it side by side with human decision makers. That can give you an expected result. That can be tricky to do, but if you can. I have 5 minutes left, so we'll very quickly go through the food for thought. These are just things that you want to think about. So, all humans make decisions, and they're all biased in some way. Do we want human decisions in our app, or do we want correct ones? Something to think about. You know, if AI is replicating our intelligence, human decisions do come with biases. Do we want to get that out of software? Something to think about. And what if the AI replicates human intelligence? Do we accept some of the inconsistency and the human decision making? It's not an easy question, and there aren't an easy answer. So the other issue that we need to consider is the speed. You know, machines treat all events as equal. Humans recognize the difference between some things are more important than others. How do we code for that? It's not exactly easy. We can train with data and use algorithms, but it's something to think about. And then software, the thing is, it can't improve on answers. So we may not completely understand the system. Sometimes disasters can happen because software behaves in an unexpected way, but human oversight has to prevent those wrong decisions. But the problem is the machine's already made the decisions before we look at it. So that's where the speed comes in. So my conclusions here are you can't make intelligence from code. Algorithms can't think like humans, at least at this point. There's always going to be bias because the learning systems are what we train. We've made the decisions. There's no easy answers to this. And if we choose the data, it's very likely to be biased. So what I want you to remember is choose wisely. Choose your data wisely. And I have a few references here, and I'd like to thank you very much. And yeah, we have time for some questions.
Oh, yes, thanks a lot. The first question, I heard about political bias in American ChatGPT to promote a specific candidate. After it could be forced to be biased, can we trust it?
That is a really, really good question. And I think, you know, when it comes to voting, it's what every voter's going to have to think about and going to have to determine, yeah, I mean, I don't think I'd trust it.
That would be interesting to ask the question that who shall I vote for? What would ChatGPT say? I don't know. Anybody knows the answer? Okay, we don't. How can we have objective acceptance criteria if we as humans are biased ourselves? How can we overcome our own biases?
That's also a very, very good question. And there again, it comes down to the data. You just need so much different data. Work in teams, you know, because I think, you know, your biases may be a little different from mine. So if your whole team participates, if you get some users participating with the data selection, you're likely to spread the risk of biases.
Okay, next question. What types of cognitive biases do you believe can be more prevalent in AI systems?
Well, I mean, we did talk about the latency bias, the data selection, the interaction. I think also one that is very difficult for us as testers is the confirmation bias. In the confirmation bias, we believe something that we already we look at data when we look to make a decision, and we tend to lean more heavily on the data that we know to be true. No, quotes here. And so that if we're looking at the results, if we're already thinking, if it's confirming what we believe, that could be a confirmation bias. So it's good to have multiple people look at the results.
Would it make sense to use another AI for testing the bias I want to implement in my AI?
I think if it's worth a try. You know, I mean, that other AI is probably going to have some biases too, but it's sure worth a try.
Did you try testing an AI's answer with another AI that is taught with totally different data?
I haven't. Well, yeah, I mean, that's a tough one. I mean, it's probably something you could do. You definitely, if you're seeing results that you don't think are right, yeah, I would totally scrap it and go with very different data.
Thanks. How to make stakeholders and the owners understand that we need to maybe spend more money to have data without bias?
Well, I think that maybe talking to them about the difference in how you test, like we discussed here, that the testing is going to, the biases are harder to find. The testing is going to take more time. Talk about the criticality. If you're doing like a resume thing and it selects, the Amazon thing for women, in the U.S., it's illegal to discriminate against people when hiring. So you could tell the stakeholders we could get sued if we don't properly talk to a diverse group of candidates. And even, and in the safety critical domain, yeah, I mean, you don't want somebody to, you're testing AI on a self-driving car, you don't want somebody to die. Point out the risk.
Okay, maybe one more from Anna, our last speaker. Do you see bias risks when we use AI-based testing tools or ChatGPT to help us with testing?
Oh, I do. Oh, absolutely. Again, how's ChatGPT? It's AI, right? How has it been tested? I definitely think you could see the bias there, and you probably should be looking for it as you go through your tests. As Anna mentioned, you got to really assess what ChatGPT is coming up with. Well, look at it with an eye to bias as well as, is it the responses that you wanted?